All right, we're going to graph this rational equation. The first thing to do always, if you can, is to factor, and this does factor. It factors into x squared plus 1, x squared minus 1, and this factors into x plus 1 and x minus 1. It's good to know those things. The denominator factors into x plus 2 and x minus 2. All right, so now that we see that, we know that on our graph there's going to be a vertical asymptote at -2 and at +2. So that will look like that. That's -2 and that's +2, vertical asymptotes. And we also know that there's going to be a 0. There's going to be a 0 at -1 and at 1, because you set the numerators equal to 0 to find your zeros, right? And this one doesn't yield any more zeros. Those are imaginary. So at -1 and +1, we have zeros. So that would be here and here. Those are my zeros. Now we know there's going to be a slant asymptote because the degree of the numerator is more than the degree of the denominator. So to find that slant asymptote, we do long division. So x squared minus 4. X squared minus 4 is on the outside, and x to the 4th minus 1 is on the inside. Notice I'm leaving like plus 0x cubed plus 0x squared plus 0x. I'm leaving space because that I might need it. So let's do our long division trick here. This x to the 4th divided by x squared is x squared. Multiply it there and put it here. So that's x to the 4th minus 4. So I don't need that there. X to the 4th minus plus 0x cubed. I can write that in to hold its place. Minus 4x squared. But remember, I'm subtracting that. So those go away, and this becomes a positive 4x squared minus 1 plus 0x minus 1. How many times does this, what's that divided by that? And that would be positive 4. So multiply that to both of those, and you get 4x squared minus 16, and remember I'm subtracting that, so those are gone, and I just get plus 15, which doesn't really matter. This is what matters. That's my slant asymptote. So y equals x squared plus 4 is my slant asymptote. All right, so x squared plus 4 would be up here, and it would be like this. It would be an asymptote that goes like that. That's x squared plus 4, x squared plus 4. And I'm doing that, well, I'm going to have to shift my graph a little bit. Let me redraw this. Here's my zeros. Remember, my zeros were at 1 and -1, so they're here and here. And my asymptote, my slant asymptote is y equals x squared plus 4, so it's gonna have 0, 4, and it's gonna go over 1 up 1 on both sides, and over 2 up 4 on both sides. So my graph is gonna look like this. Roughly. Okay, so now let's figure out how to actually graph this. Well, we know that we know where my zeros are. My zeros are here and here. And so what I'm going to do is I'm going to plug in 0 and see what my value is. 0, what? In other words, I'm going to find my y-intercept. You can see if you plug in 0 for x here and here, you get positive 1/4. So 0, 1/4 is my y-intercept. 0, 1/4 is right there, which is good because it does what I thought it would do. It's going to go down like this here and here. I don't want that going up, crossing any of those asymptotes. So that means that my other part of my graph must be up here in this little section right up here. It's got to be like there. I know this is really tiny, hard to see, and right there. That's what my graph is going to look like. The purple is my graph. I know it can't be in this section because then I would have another x-intercept, and I know it can't be in this section because I'd have another x-intercept, and it can't be in this section because it wouldn't be a function because of the vertical line test, because I've got my function down here on that part of the domain. So the asymptote, those asymptotes have to be utilized like that, and that's roughly what the graph looks like.